These are notes over 2.2 acceleration. So the definition of acceleration is just the rate of change in velocity. Okay, so remember velocity is displacement divided by time. Okay, very similar to speed, except that there's a direction. Okay, so acceleration, the units for them are meters per second squared. Okay, and it's the result of either speeding up, slowing down, or changing direction. Okay, because that means that our velocity is changing. So when an object slows down, its acceleration is negative. So if you think about a car coming to a stop sign, okay, it's slowing down, its acceleration is negative because it's decelerating. Okay, this next one I have a typo, but it should say when an object speeds up, its acceleration is positive. Okay, so if you think about an object falling towards the ground, it's speeding up. It's going faster and faster and faster. That actually has a positive acceleration. Okay, changing direction also causes acceleration, even if the speed is the same. So if you think about cars, you can set your cruise control so that the speed stays constant. Okay, but if that car going, let's just say it's going 30 miles per hour, takes a curve, okay, it's changing the direction. Might have been going north and around the curve, now it's going east, that is considered acceleration as well. Okay, so one key thing is if an object is going along a circle path, it has centripetal acceleration. So if you've ever had a bucket of water and you've spun it around with your arms to kind of keep the water in there, that's a centripetal path because it's going in a circle path. So even though you're moving your arm at the same speed around and around, it is accelerating because it is changing direction. So the formula for acceleration is V, which stands for velocity. And you'll see there's a tiny where it says final. So that's our ending or final velocity minus V initial, which is our initial velocity or our starting velocity, divided by time. Okay, so we're going to do a few of these practice problems in using this formula. Okay, and the trickiest part about it is just figuring out which is our V final and which is our V initial, and then figuring out what the time is for that. Okay. To start, a roller coaster's velocity at the top of a hill is 10 meters per second. 2 seconds later, it reaches the bottom of the hill with a velocity of 26 meters per second. What is the acceleration of the roller coaster? Okay, so you'll see that you have off to the side, I have each of the variables that we need to find. Okay, so acceleration is what we're trying to find, so I put a question mark. Okay, VF is our final velocity or ending velocity. Okay, so if we started at the top of the hill at 10 meters per second, and then 2 seconds later, we reach the bottom of the hill with 26 meters per second. 26 meters per second is going to be our final velocity. So 26 meters per second. Our initial velocity is going to be what it was at the top of the hill, so 10 meters per second. And our time that it took was 2 seconds. Okay, so now we're just going to use the formula A equals VF minus VI all over T. So if we plug in what we know, so VF is 26 minus our VI is 10 all over our time of 2. And so whenever we plug this into the calculator, we should get 8. And then the units, like I said in the notes, is meters per second squared. So 8 meters per second squared. For the next problem, a roller coaster is moving at 25 meters per second at the bottom of a hill. 3 seconds later, it reaches the top of the next hill, moving at 10 meters per second. What's the acceleration of the roller coaster? Okay, so this time we're starting at the bottom of the hill, and the starting velocity, which is VI, or initial velocity, is 25 meters per second. Okay, and then 3 seconds later, so that's going to be our time, 3 seconds, it reaches the top of the hill, moving at 10 meters per second. So that's our final velocity, is 10 meters per second. Okay, once again, we're going to plug it into the formula of VF minus VI all over T. So A equals VF is 10 minus the VI, 25, all over time of 3. Okay, so whenever we put this in our calculator, 10 minus 25 divided by 3, we get negative 5 meters per second squared. Okay, and so this makes sense because we're slowing down. At the bottom of the hill, it was going super, super fast, and then as it climbs the hill, it's going to get slower. Okay, so that's why we have a negative acceleration, because it's slowing down.